Even though you might not have witnessed them at that point in their development, every giant was once a baby. The James Webb Space Telescope, JWST, NASA's most sophisticated space telescope, is providing insight into the early years of the universe's history that were previously unreachable. Our view of the cosmos is changing as a result of the amazing instrument's discoveries, which have created new opportunities for studying cosmic evolution. When the JWST first took its deep field photograph in June 2022, it revealed a multitude of distant galaxies, revealing groundbreaking discoveries. This landmark was a significant event in astronomy history rather than merely a normal observation. In ways we never would have thought imaginable, galaxies suddenly started to show up out of the shadows of space and time. For the first time, the universe started to appear far wilder than we had ever imagined. The formation of galaxies from what scientists consider to be the dark ages of the universe prompted serious concerns about the accepted scientific models used to explain our universe. Both professional astronomers and amateur stargazers are excited by these discoveries, which not only cast doubt on accepted hypotheses, but also spark a fresh curiosity in the universe's evolution. A cosmic panorama full of surprising occurrences has been unveiled by the JWST's capacity to look farther into space and time. The JWST discovered hundreds of galaxies, not just a few, which caused astronomers to rethink their theories about the origins of the universe. An Austin astronomer called Stephen Finkelstein made one of these important discoveries when he discovered a galaxy that he dubbed Maisie's Galaxy in honor of his daughter, whom he saw on her birthday. This human touch gives the scientific process a human touch and serves as a reminder that these discoveries have stories and real-world links behind them rather than just being statistics and data points. At first, Finkelstein and his colleagues estimated the galaxy's age to be about 290 million years after the Big Bang and thought it had formed practically instantly after the event. But after using more sophisticated tools to conduct additional investigation, they found that this galaxy is roughly 100 million years older than first believed, solidifying its position as the oldest galaxy ever seen, having formed just 390 million years after the Big Bang. The question of how many other galaxies like Maisie's Galaxy exist is brought up by this revolutionary finding. The galaxy with the oldest observed record may not keep the top rank for very long. The JWST team is currently evaluating roughly 10 other galaxies, some of which may be even older than Maisie's Galaxy. As Harvard-Smithsonian Center for Astrophysics Fabio Pacucci put it, "We're seeing a rise of massive galaxies faster than we previously thought." Given that some of these early galaxies are only thought to be tens of millions of years old, our knowledge of how galaxies develop may need to be drastically revised. These results may have important ramifications for massive dark matter formations called halos, which are believed to have shaped early galaxies based on our cosmological models. The current knowledge of how galaxies develop and change throughout cosmic time is called into question by the discovery of large galaxies arising so quickly after the Big Bang. Scientists are now asking important questions as a result of this. Did we underestimate how quickly galaxies were forming? Were our cosmic evolution models lacking something? Furthermore, there are issues associated with the JWST disclosures. There are still some troublesome and maybe model-busting early universe candidate galaxies. The first of these is a class of galaxies discovered by a group of researchers at Australia's Swinburne University of Technology. Only 750 million years after the Big Bang, the scientists discovered galaxies with billions of solar masses, which is similar in weight to our Milky Way. According to reports, these galaxies are compacted into formations 30 times smaller than the Milky Way and are 10 to 100 times larger than galaxies previously discovered in this epoch. The fact that these galaxies seem to be supporting a lot more stars than astronomers initially believed is even more fascinating. The cosmological standard model has been questioned, casting doubt on our basic knowledge of how huge objects accumulate over time. This poses significant queries regarding the mechanisms governing the evolution of galaxies and star formation in the early cosmos. Were there unidentified processes involved in the rapid formation of these enormous galaxies? Renowned theoretical physicist Michio Kaku has written a great deal about these discoveries. "The apple cart is being upset by the James Webb Space Telescope," he wrote. "We now recognize that we might need to revise every textbook on the universe's origins. His observations highlight how revolutionary the JWST results are and raise the possibility that they will change our understanding of cosmic evolution. Kaku highlights that these groundbreaking findings force us to reconsider our most basic beliefs about the universe. We always thought that galaxies took billions of years to form, Kaku said, going into additional detail about the consequences of these findings. Only a few 100 million years after the Big Bang, we are now discovering enormous, well-formed galaxies. Everything we believe to be true about the universe is altered by this. He underlined the necessity of a paradigm change in cosmology, arguing that the JWST's revelations of the complexity and speed of galaxy formation may not be sufficiently captured by the current model. When we consider the bigger picture, it is evident that the JWST is more than just a telescope. Rather, it is a groundbreaking instrument with the power to alter the course of cosmic history. The consequences of the findings so far go beyond specific galaxies and call into question the foundation of cosmological theory itself. The issue of galaxy formation timescales is so raised. A galaxy like the Milky Way, which contains over 100 billion stars, many of which are billions of years old, was thought to have formed over billions of years, according to conventional wisdom. 6 galaxies, some of which are up to 10 times larger than the Milky Way, have been discovered by the JWST to have existed only 500 million years after the Big Bang. These results run counter to earlier hypotheses. Primordial galaxies that are only 500 million years old and larger than the Milky Way shouldn't exist. Michio Kaku voiced his worries about these results, implying, "There's a problem. Our theory of the universe's creation might need to be revised." These findings have broad ramifications, compelling researchers to re-examine fundamental ideas in cosmology and investigate different hypotheses about how galaxies evolve. The JWST not only found galaxies farther away, but it also found Milky Way-like galaxies near the end of the universe that shouldn't exist based on current physics. The gas in many of these early galaxies was so brilliant that it might outshine the stars that were developing inside of them. This new knowledge shows how frequent such gassy, newborn, shimmering galaxies were when the cosmos was only 2 billion years old, 13.8 billion years old. According to current observations, about 90% of the galaxies had extreme emission features, which denoted that they had a sizable amount of blazing gas. Astronomers discovered the most distant example of a galaxy that resembles our own Milky Way while researching these early galaxies. When the universe was only 2 billion years old, the recently found spiral galaxy, known as Sirius 21112, seems to have had a bar of gas and stars slicing across its center. This begs the fascinating question: how could a galaxy like the Milky Way have existed at such a young age in the history of the universe? The Milky Way, our own galaxy, is a spiral galaxy with a bar-like structure. Scientists believe that the Milky Way's bar revolves in a cylindrical pattern, directing gas into the core of the galaxy and igniting star formation explosions. Astronomers once thought that this galactic structure signaled the end of a galaxy's early stages, and that it should only be observed in more mature galaxies, possibly ones that existed midway through the universe's development. In the past, astronomers believed that there were relatively few barred galaxies in the early cosmos based on findings from the Hubble Space Telescope. On the other hand, the JWST's findings are changing our perception. Barren spiral galaxies might not be a new phenomenon in cosmic history, according to the data gathered. Galaxies similar to our own existed about 12 billion years ago, when the universe was only 15% of its current age, according to the discovery of Sirius 21112. This finding has significant ramifications. Since Sirius 21112 is seen at a redshift of 3, it took over 12 billion years for its light to reach the JWST. Given that galaxy bars are thought to have formed roughly 4 billion years into the universe's existence, this is unexpected. The physical conditions of the early universe would have prohibited the formation of such barred galaxies, according to the mainstream model of cosmology, but here we are confronted with data that defies long-held assumptions. Scientists wonder what is happening because theoretical predictions from cosmological simulations find it difficult to replicate such systems at these early epochs. "We now need to understand which key physical ingredients are missing in our models," said one of the discovered experts. "If something is missing, we need to find it. The scientific investigations that have influenced human thought throughout history are similar to this attempt to comprehend the early universe. Every significant advancement in human knowledge, from Galileo's initial star sightings to Hubble's groundbreaking research, has been greeted with both enthusiasm and skepticism. The JWST pushes the limits of our knowledge while standing on the shoulders of these giants. And if you think the shocks stop here, think about this. Dark matter, a mysterious substance that cannot be directly observed since it does not interact with light, is thought to make up 85% of all stuff in the universe. As early as 380,000 years after the Big Bang, dark matter is believed to have been essential to the evolution of galaxies and the birth of stars. But according to JWST data, at least in the instance of Sirius 21112, when the universe was around 2 billion years old, conventional matter, not dark matter, dominated galaxy evolution. This is an important finding because it demonstrates that baryons, the common stuff that makes up you, me, and everything we see, rather not the elusive dark matter, were the primary force behind this galaxy's evolution. Our knowledge of cosmic evolution and the functions of many types of matter is further complicated by this new viewpoint. It is clear that the James Webb Space Telescope has ushered in a new era of discovery as we explore this fascinating area of cosmology. These discoveries challenge the fundamental basis of our knowledge of the cosmos and are not just scholarly. They are revolutionary. The once dark mysteries of the cosmos are now accessible to us, unveiling a more vivid, rich, and complicated world than we could have ever dreamed. To sum up, the James Webb Space Telescope is more than just a technological wonder. It is a lighthouse that illuminates the universe's deepest nooks and crannies, challenging us to reevaluate our current understanding and take into account the enormous potential that lies ahead. As we stand on the brink of new knowledge, we welcome everyone to join the conversation as every new discovery forces us to reevaluate our understanding of the universe. How do you feel about these results? What are their consequences for cosmology's future? This is your place, a place full of wonder, exploration, and limitless possibilities. So please share your ideas in the comments section below and remember to subscribe to our channel.